Okay, the topic called moment. Moment is about rotation, right? What we talked so far, we said that, okay, if you want to talk about equilibrium, if you want to talk about statics, in statics, we came to a concept of sum of f of x equal to 0, sum of f of y equal to 0. But this is not sufficient, right? We have a structure where the sum of f of x is 0, sum of f of y is 0, but the whole thing is not in equilibrium. Okay, let's consider this pen, right? I apply forces to this pen. If I apply a force like this with the same amount, right? I apply 10 Newton this way, 10 Newton this way. But this will create rotation, right? This is a rigid body. It's not a particle anymore. Now, besides sum of f of x, sum of f of y, I need to bring a new equation, and that's what we call it sum of moment equal to 0. So now, how the rotation is happening, how the moment is created. The moment is equal to force times distance, or F times d. But basically, what distance? Not every distance creates that rotation. If I have an object like this, and I have a pin connected here, if I apply the force like this, it wouldn't create any rotation, right? Because if you apply the force like this doesn't create any rotation, because if this is point O, there is no rotation from this. So the distance that I put here is called perpendicular distance. Okay, perpendicular distance meaning that if your force is in x, your distance is in y, and then vice versa. I have a couple of examples that I want to work on them today, so to get you more familiar with the concept. So let's look at the first example. In the first example, I have a force of 100 Newton applied to one side of the beam, and the distance is 2 meters. I want to see how much moment is created. By the way, in 2D, the moment is about z-axis. All the rotation is about z-axis. The force applied on x or y, but the rotation is about z-axis. Now, in this case, z-axis is perpendicular to this. Look like where I hold the pen. If I apply 100 Newton with the distance of 2 meters, the moment simply will be moment is equal to 100 times 2 will be equal to 200. Why I put the 2? Because it was perpendicular. I didn't need to do anything else. The distance and the force are perpendicular together. Now, the question would be, okay, 200 what? So this is Newton. This is meter. It's going to be Newton meter. That's the unit for moment. Now, the other question I have is that there is the direction of the rotation. If you put 100 here, if you look at about point O, the direction of rotation is clockwise. Now, the clockwise rotation is the clockwise rotation, we use negative for clockwise rotation. So basically, the rule is that if you go like this, if you go counterclockwise, it's positive. Anything clockwise will be negative. So basically, I'm going to put a negative here, and that negative stands for clockwise. Okay, let's move on to the second example. So in the second example, I have a force of 50 Newton and it's applied to point O. What distance I need to use this time? Should I use 2? Should I use 0.75? Or should I use a combination of both? So I need to do a little bit of thinking. If this 50 Newton was coming all the way up, right? If the force 50 Newton was applying instead of here, was applying up there, it wouldn't create any moment, right? So this moment is created is just because that 0.75 is perpendicular distance. Now, in this example, it didn't matter the force 50 was applying here or was applying here. It had the same concept. It had created the same rotation. Now, in this case, the moment will be equal to 50 times 0.75. Now, why use 0.75? Because the force was in x. the distance will be in, no doubt about it, because x and y are perpendicular together. So 50 times 0.75, I can calculate how much moment is in here. Yeah, how much is that? 37.5. Is this clockwise or counterclockwise? Again, I have to put my imagination of thinking. If I apply the force there, whether it rotate clockwise or counterclockwise. In order to show the concept to you, I'm going to use my calculator, right? I'm going to hold here point O, and I'm going to apply the force the way it is. The rotation would be clockwise. Negative, exactly. So I'm going to put minus 30.7. I'm going to put a note for myself. This rotation is clockwise. Now, let's make the problem a little bit harder. In this case, I have 40 Newton going down, and then I like to do the rotation about point O. I'm looking for perpendicular distance. The force is in Y. The distance I need to find will be on the X. So now I need to go from the force all the way to the point, because the rotation is going to happen from here all the way to here. So to find the perpendicular distance, this distance is 4, right? Distance here is 4. I have to add the 4 to cosine 30. So the overall distance for this will be 4 plus 2 cosine 30. Your overall moment about point O, again I forgot to put the point O here because we do the rotation about the point, is equal to 40 times 4 plus 2 cosine 30. And if I do that, 40 times 2 times 4 plus 2 cosine 30, we got 229. It still is clockwise. If you look at the rotation, this will go clockwise. So I put the negative here and I call this. What's up? How come clock? I use the 2 feet. I use the cosine 30 of the 2 feet. Because the 2 feet was in the angle, and the only portion of the 2 feet which was on the x-axis was the projection of it on the x. Right? Was just this side of it, which is the adjacent side. Okay, what did you want to add, Kareem? Exactly. So we look at that as a right triangle, and that triangle, the hypotenuse here is 2 feet. The angle here is 30 degrees. So this distance will be 2 cosine 30. Yeah, very good. So but 2 cosine 30 feet. And the unit for here will be pound into feet. Moving to the third example. Sorry, the fourth example. On the fourth example, we have the force of 60 pounds. And then we want to see the rotation of this about point O. Now the angle of here is a 45 degrees, like this. Before I move on, I look at the force. The force is in the x. I need to find the distance to the y. And that distance to the y is the same method we went here. You can create a right triangle again. And I have this angle here 45 degrees. The hypotenuse is 1 feet. So the distance which is on the y will be sine, right? So it will be 1 sine 45 degrees. Now, in order to summarize my answer on this part, I'm going to say moment about point O is equal to 60 pounds into the distance which is 1 sine 45. The answer for this. Okay, before I move on, I'd like to know whether this is clockwise or counterclockwise. Yeah, some of you can see it easily as counterclockwise. Some of you may have difficulty with it, right? Well, how this is counterclockwise. So what I do, I use like this. So I put the calculator here. This is 0.0, right? And I apply the force. Let me just to bring the calculator up here. This is 0.0. And I'm actually applying the force at, like, again, assuming that you have some cut here, right? If you apply the force, you're going to go counterclockwise. That will be the rotation of it. You can use a piece of string, piece of napkin, anything that can allow you to see that rotation. That will be good to go. Even like something like this. You see? Even something look like this can be used to see the direction of the rotation. If I apply the force like that, it's going to go clockwise. Again, with all my finger, it's so difficult to see it, but this is how it looks like, right? If I apply the force here, I'm going to rotate counterclockwise. The last one, I have 7 kilonewton. That's the force. I need to find the perpendicular distance between this 7 kilonewton to the point O. So the force is 7, moment which was force times distance. How much would be the distance for this? So you have to 3 exactly. So because the force is in the x, the distance will be on the y, right? So the force is in the x, the distance on the y will be this distance. That's the distance that create the rotation. If this force 7 was here, it wouldn't create any rotation. And because of this offset, which is 4 minus 1, 3 meter, that create the rotation. Again, the unit for this will be 21 kilonewton meter. Okay, I need to know the direction of rotation, whether this is going to go clockwise or counterclockwise. Yeah, it is counterclockwise, exactly. So if you look into the object, it's going to go like this. This will be counterclockwise, which is going to be positive. So I'm going to put CCW here and CCW here, counterclockwise. Okay, thank you very much. This was actually a very brief lecture. Now, we want to use this to solve more complex problems, right? So complex problem meaning that if I have a problem like this, what I would do with this. How can I determine the moment of each of these 3 forces about point A here? Now, as the problem gets more complex, we need to find a method for doing this. When we have a bunch of different forces, the method, again, the straightforward method first will be break forces into x, y components. Step 2 will be to find the moment of each component about the point. Oh, let's make it our job very easy. Let's do that. So the first thing I do, I break the forces in x and y component. I have 250 Newton here. The angle is 30 degrees. So I break this in x and y component. I'm going to get here 250 cosine 30. Remember, that's the adjacent. And I'm going to get 250 up here, 250 sine 30. Move on to the next one, the F2. F2 I have 300. On the X will be 300 cosine 60. On the Y I'm going to get 300 sine 60. Now on the X for F3, you can find the angle or you can just use the ratio. So this will be F3, which is 500. So 500 times cosine of 3 over 5. So again, if you calculate the angle here, you can find it as, again, I'm going to call this phi. Phi is equal to tan inverse of 3 over 4, which is 36.9. So it will be 500 cosine of 36.9. Cosine of 36.9 is already 4 over 5. And then this side will be 500, 3 over 5. This is 3 and this is 5. I don't want to go over more into philosophy of this, but that's how you can use it. Now I have 6 babies I need to take care of them, because I break those 3 forces into 6 components. For each of these components, I need to find the perpendicular distance to the point A. Okay, let's go for it. So in order to do the moment, let's me just to label them, because it's the first time we are doing. This will be the 1, this will be the 2, the third component, the fourth component, the fifth one, and then the sixth. The first component, 250 sine 30 with the A. Does it create any rotation? And why it doesn't create rotation? So we know if the force crosses the point, moment is 0. If you look at 250 sine 30, that crosses point A. When it crosses point A, there is no rotation. It's the same example that you take the Allen wrench, not the Allen wrench, this kind of wrench, right? And then apply the force this way. This doesn't create any rotation, right? It even looks very dumb if you do that, because you are ripping the screw, the knot. You are not doing anything. The force has to be perpendicular. So in this case, 250, the moment of this is 0. So I'm going to say my total moment about point A is equal to, for the first one, I have 250 sine 30. The distance for that is 0, right? Create no moment. Let's move on to the second one. So this is the first component. In the second component, I have 250 cosine 30. 250 cosine 30. What would be the perpendicular distance for that? (250 cosine 30 is here. What's the perpendicular distance? 2, exactly. To the point A is 2. So is it clockwise or counterclockwise? Clockwise. We are all in agreement. So that will be negative. And this negative is because it is clockwise. Now, this one is the force, and this one is the distance, right? The perpendicular distance. The force was in the y, the distance was in the x. Let's move on to the third component. The third component, I have 300 sine 60. What would be the perpendicular distance for that?
5 meters.
Exactly, 5 meters for that. And that's going to go clockwise again, right? And this will be 9, so this will be clockwise. And this is the force which is in y. The distance will be in x. For 300 cosine 60, similarly that will be 0, right? I don't need even to do anything for that, because 300 cosine 30 is crossing point A. So 300 cosine 60 times 0. I have 2 more things left. One, this one, the other one. So for 500, 4 over 5, which is the fifth component. 500 times 4 over 5. Is that clockwise? What's the distance for that?
Clockwise.
It is clockwise. We are all in agreement. What's the distance for that? In order to find the distance, remember the force is in the y, the distance will be on the x.
X.
Okay, just close your eye. What distance is in x? 5. That's it. Don't do any judgment. So this distance for this is 5, which comes from here. The last one, which is 500, 3 over 5. What will be the distance for that? This force is on the x. The distance will be on, exactly, on the y, which is going to be 4. Clockwise or counterclockwise? Counterclockwise. It's a little bit hard to imagine, but you can always use something like this, right? the Q-tip is that word we already used like 1,000 years ago. So you can just apply the force like this, and it's going to show you it's going to go counterclockwise. So you can add all these numbers together, and that will be your resultant moment about point A. So this will be sum of moment about point A, which is going to be whatever. Okay, thank you for listening to this video. I'm going to stop it somehow.